So let's begin. So what do you think? Little brainstorming session here. Blake, I need you focusing on me, not the ladies, please. How are static and current electricity the same and or different? You can just take a sheet of paper, just any old thing, scrap paper, whatever you got. No, I'll tell you when you need to calculate. Okay? I want you to make sure there's like 2 columns. Right? Just with your, whoever's sitting beside you, just a quick little thing here. How are they the same and how are they different? You've got about 90 seconds or the amount of time it takes me to do attendance. Go. How are they the same and how are they different? Go. Who wants to share one, how they are the same? Jeff? Okay, there are types of electricity. I'll just write real messy. Types of electricity? Yeah, we're still on same. Okay. We were talking over here. Both use positive and negative, right? Okay, Jeff, you got something else? You have nothing different now? Okay, anyone else want to add something different there? I'm going to also say, which is kind of like positive and negative, I'm going to also say involve some type of charge, right? Involve some type of charge. How are they different? Anybody know? That's okay. What do you think? One is natural, one is man-made.
Got a reminder on an email?
I'm guessing. Marley's saying, okay, which one's man-made, which one's natural?
Natural.
Static is natural? Like what if I rub a balloon in my head? How natural is that? I mean, that's benefited. You think static is man-made?
No.
And current is natural?
No. I don't even know.
Okay. How about we say, we'll just save that thought maybe, and then we'll anyone else on how they're different? There's really only one major difference that I'm looking for. Friction? One involves friction, the other doesn't?
No.
Yeah.
Oh, yeah, that's not the same.
Okay, so we're not really sure. Should we leave this one blank maybe? Maybe what we're going to find out, right? Okay. No? Go ahead, give it a try. Oh, you're disappointing me. Okay, well, let's begin. Okay, do you remember the fantastic pie plate demonstration? You may have even gone home and said, Mom, can I get a pie plate, a styrofoam plate? No? No one did that?
No.
It didn't work.
Well, remember, we charged the styrofoam by rubbing it, right? Remember we took the Amy Farrah Fowler sweater that we cut up and we rubbed it on the styrofoam plate. And then the charge was transferred to the metal plate. Remember that? And then it became negative and electrons moved, and I'm going to underline moved. Electrons moved to our finger and we got a spark when we touched it. Electrons moved. Moved. What if there was some way, because once you sparked it, right, like did it keep working over and over and over again? Like you might, if you got really lucky, especially in the winter when the air is very dry, you might be able to rub it once and get 2 or 3 sparks out. Okay? Pardon me? We're getting to that. Okay? So what if there was some way to keep rubbing the styrofoam, keeping it constantly charged? Like what if there was some way that said the styrofoam plate, Blake, you're not listening to me. What am I talking about? I'm on about them. Huh? Okay. If there was some way that we could keep rubbing, say, the bottom of it while you someone else keeps touching that the metal plate, you might be able to keep getting a shock, right? There was some way to keep that styrofoam plate constantly charged. Okay? Then we would get what? What would happen? We could keep that styrofoam plate charged. Would we get multiple sparks, do you think? You think the sparks would keep on coming? Ladies, I need you listening, please. Okay? The charge would build, and then it would be constantly discharged through your finger. You can keep touching it, keep getting a spark. Over and over and over again. But there's no way to do that. Not really. Enter the Van der Graaf generator. The 1960s progressive rock band, right? These guys. You know this band? You met them. I've never heard of them until I Googled Van der Graaf generator. I was looking for a picture, and lo and behold, this is what popped up.
Do not read those people.
This is what they sound like, in case you're interested. I was talking about, right? Yes, this is the Van der Graaf generator that I was talking about. Now, what do you think would happen if the Van der Graaf generator, what it does is, no, there's a belt inside, right here. Can you see it? It's kind of like almost like a stripe right there. There's a belt inside the Van der Graaf generator, and it goes around and around and around and around, Blake. Right? And because of that constant friction, it's like taking your Amy Fair Fowler sweater. You'd like to see this. It's like taking that piece of wool and rubbing that styrofoam plate over and over and over again. Where does the charge get deposited? Right on that big dome there. If I took a whole bunch of pie plates and put them on top, what do you think would happen? What do you think would happen? We'll see. I'm going to show you. So, I would like you on an internetable device, and I forgot that Mr. Love will be coming to use the laptops. So, you're going to have to use, you guys are actually, Blake, I need those chairs down. Okay? On an internetable device, on Schoology, there is a quiz that you can Google for the answers, and I'm trying to show you here. You can get your own devices out. I was hoping that would be quicker. Okay? I'm going to give you a handout. Okay. What I was hoping that you would get out of that was some answers. Okay? On that sheet, you've got the sheet, and that is what I've got on the screen here. Current electricity is defined as the amount of charge per unit of time. Write that down. Amount of charge per unit of time. Amount of charge per unit of time. Right there on the sheet where it says current is defined as. Amount of charge per unit of time. And this is the formula. You should have discovered that current, the letter for current is I. Why do they not use C? Why not use a big C for current? Exactly, it's used for something else. It's a very special constant. It's the speed of light. So that's why C is not being used. The problem with I is that it looks like a 1. So I stands for current. What do you think Q stands for? Charge. Q stands for charge. Why not use a big C? Use for something else. They use Q. T's the easy one. Time. Write those down so you know what they mean. I is current, Q is charge, T is time. Now, those of you with some math background can probably rearrange this formula. Okay? It's also written, these are the same versions of this formula. Q equals IT, and T equals Q over I. Have you guys ever seen the magic triangles? Has anyone ever showed you that?
No.
No? Okay, good. I'm not going to show them to you. The magic triangles are good for some people, bad for others. I prefer to just keep them a secret. Know these 3 formulas. Know those 3 formulas. They're all the same, just different versions, whether you're solving for I or Q or T. Oh. Okay, has everyone got those formulas written down? Okay, now, I would like to point out that time is always measured in seconds. For physics people, time is always in seconds. So I just need to remind you that there are 60 seconds in a minute, and 60 times 60, which is 3,600 seconds in an hour. Okay, fill in those blanks there. You need to know that. 60 seconds in an hour, 60 seconds in a minute, 3,600 seconds in an hour. So I want to spend just a couple seconds, little joke there, doing some sample time conversions. How many seconds are there in 4 minutes?
40.
4 times 60, 240 seconds. Drop that in there, sample time conversion. Molly, get it down. I need you watching. You know what's going on. Here, right there. How many seconds then in 0.75 hours? Blake. How am I going to do this, Blake?
I don't know for sure.
You don't know for sure. Yeah?
Yeah.
Well, first of all,
45
a
minutes.
couple different ways here. We can convert hours to minutes. So 0.75 hours is how many minutes?
Oh, it's 45.
45 minutes?
I did 60 times 45, 2700.
What's 45 times 60?
2700.
2,700. Good.
Bingo.
Okay. Hokey pokey, that's what it's all about. Solving electricity problems. Now I stole these steps from some other smart teacher online. Blake, I need to see your eyes, Matt. Okay? I'd like you to do your problems this way. All problems must be solved with the following steps to get full marks. State the variables, given numbers, and the unknown one. Write the formula to use. So very important when I teach grade 11 and 12 physics. I insist that students write the formula. Substitute the given formula numbers into the formula. Solve. Check that units are written after the final answer because that's important. And check that all equations have variable symbols or numbers before and after the equal sign. You can't just have an equal sign with nothing on the side. I'm giving you 3 sample questions. Do you see them on the next page? Flip your page. You should see 3 sample questions, and then after that, you're going to have a chance to do some, Blake. Blake. Sample question number 1 at 240. Now, we didn't go through all that stuff, did we? We didn't get through that quiz stuff. Unfortunately, maybe we need to go back here. Let's go back to here. What do we measure these things in? I equals Q over T. I'm going to insert a blank page here. I equals Q over T. We know that I stands for current, Q stands for charge, and T stands for time. What do we measure current in? Anyone know what the unit, like 10 what? Like speed is measured in like kilometers per hour or something like that. What do we measure current in? Anyone know? The word is amps. Amps or amperes, named after a scientist whose last name is Ampere. Yeah, and school, I wanted you to do that, and we kind of had some issues there. Jeff.
I'm stretching.
So what do we measure current in? Jeff? Amps, excellent. What do we measure charge in? Anyone know?
Time.
What's the unit for charge? Like I might give you something like 3 million. The word is coulombs.
Oh, God.
Coulombs. C-O-U-L-O-M-B-S. Coulombs. Pardon me? Yeah, it was on that little quiz thing that we couldn't do. And we just used the letter C for coulombs, named after another scientist. T is always measured in seconds. That's not named after anyone. Okay. You need to know those. Let's go back to the sample question here. So if 240 C stands for coulombs. 240 coulombs of electric charge passes a certain point in a circuit in 5 minutes. What is the current through that point? You're going to need a calculator. That's why I sent that message out last night. We're looking for current, right? What do we know? We know charge. Q equals, Blake, where are you going? Q is 240. T is equal to 5 minutes. Do I need to convert that to seconds? Do I need to convert that to seconds?
Yes.
Yes. How am I going to do that? Multiply by 60. 5 times 60 is 300. 300 seconds, right? Getting this down, Jeff? What am I solving for? I'm solving for current. I equals big question mark. Don't know.
So,
Okay? Let's just go back and look at those steps that I gave you.
it's Q divided by T.
Yeah.
Divided
Yeah. Whoa. Slow down. Slow. Let's go back. So, did I state the variables given numbers in the unknown formula? Unknown variable? Yes. Did I write the formula to use? No, I haven't done that yet. I equals Q over T. Got that, Andrew? I equals Q over T. That's step 2. Step 2, write the formula to use. Next one, substitute the given numbers into the formula. Where should I write the next line of the solution here? Right underneath, and your equals sign should line up. Okay? Teachers like that. Equal signs lining up. I equals. What is Q equal to? 240. What is T equal to? 300. Notice how I put the numbers in place for the letters. I put the numbers in place of the letters. Let's have a look here. I substitute the given numbers in the formula, and now I need to solve. Now here's where your calculator comes into play. I need to go 240 divided by 300. Line up your equal signs. I equals what's 240 divided by 300?
0.8.
0.8. 0.8 what?
0.
What do we measure current in? Amps, or just the letter A? 0.8 amps, Blake. 0.8 amps.
No.
Okay, question number 2, sample. If a stereo in a home is on, there's an old-fashioned stereo. Not going to put a DVD in that one. Uses or draws. The word draw sometimes refers to how much current is being used.
Oh, hey, that's just like on an app for a guitar.
Yeah. Uses or draws 12 amps for 30 minutes. How much charge in coulombs is this? How much charge? So what do we know? We know 12 amps. I is 12 amps.
Right.
Times 30 minutes times 60 is 1,800 seconds. And I'm solving for Q. Q is big question mark. Which formula solves for Q? I gave you 3 versions of it. Q equals I times T. Do you have to put a little X in between or anything? It implies Q equals it. It's the hokey pokey. That's what it's all about. Q equals IT. Q equals I is equal to 12. T is equal to 1,800. Do the math. Okay. 21,600 coulombs. You might ask, how many electrons is that?
How many electrons are in a coulomb?
How many electrons are in a coulomb? Someone might ask that. Oh, she just
How many electrons are in a coulomb?
How many electrons in a coulomb? I'm glad you asked, Blake. I happen to know this number. I'm a nerd, and if I were ever on Jeopardy and the question is, or the answer is 6.25 times 10 to the power of 18, then I would know the question would be how many electrons in a coulomb. 6.25 times 10 to the 18 electrons in a coulomb. Do you guys know what 6.25 times 10 to the 18 means? Do you know scientific notation?
No.
Have you ever seen that before?
There's a power up.
Times 10 to the 18, that means this. 6, 2, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then one more. If I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 decimal places.
So
That's how many electrons in one coulomb. No, it's 6.25 times 10 to the 18 is
Do we write that down?
1 with 18 zeros, and then you multiply by 6.25.
Do you write that down?
You guys haven't seen scientific notation?
Excuse me.
Okay, we might have to do a lesson on
Do
that
you
then.
want us to write this down?
I think we're going to have to, yeah, I didn't realize you didn't know that.
Do you want this to read?
So, yeah, you know what, we'll talk more about that probably. I'll have to do scientific notation with you next time, I guess. Okay, so there's your answer right there.
6.2 what?
21,600 coulombs. So if I wanted to know how many electrons that would be, it'd be 21,600 times that big giant number. That's a lot of electrons. It's a lot of electrons.
Can you say that number?
6.25 times 10 to the 18.
No. Say it.
It as it's written.
That large number.
Oh, say that large number.
Oh, no.
That large number.
Oh my god.
Oh, you mean like 625 Brazilian? Isn't that a Brazilian times 10 to the 18? It's after million, billion, trillion, Brazilian. Isn't that how it goes? Nah, I'm just making fun of you guys.
So it's Brazilian.
It has no, I don't know if it has an actual, I guess it would be, well, I have to count them all. It'd be a lot. How about you guys try this one? You want to try it? Not really? Not yet? Okay, fair enough. How long will it take for 12 amps to move 1,600 coulombs of charge? After this one, you're going to be doing some on your own. I equals 12. Q equals 1,600. We are solving for time. T is equal to big question mark. Okay, for every problem I want to see those things. It's a good little step.
Who's the smartest person?
Besides me? You mean like who's got the highest IQ? I don't
I feel
know.
like Einstein and then like
Yeah, you couldn't measure it. It'd be like saying like the best kind of cookie, right? Like, how do you measure something like that?
who's that one that
Can we solve this, Jeff, before we're running out of time here?
wrote that?
So what's T equal to? What's the formula?
Q over I.
Q over I, right? Okay, so T is equal to, this time it's going to be 1,600 or 1,600 divided by 12. I cannot do that in my head as much as I'd like to.
I know it.
Do you?
It's 133.33.
Oh, okay. Can we just round to decimal 3?
Yeah.
We'll leave it like that. I'll talk more about that probably tomorrow. T equals 133 what?
No, next
What's the
week.
unit?
Next week.
What's the unit? Seconds.
Not tomorrow, next week.
Seconds, right.
We have to have seconds.
Okay, so as I said way back at the start, here I'll pause. As I said way back at the start, you will know what current electricity is. It is charges moving, that's what it is, right? It's electrons moving. Understand how static and current electricity are related? Current electricity is just charges moving. Static electricity is charges not moving. When you charged up that high plate, it was static. As soon as you put your finger on it, it becomes a very brief current because it's moving. And you need to be able to solve current electricity word problems. That's what I was talking about. I equals Q over T. Okay, I'm going to give you a chance. You've got 12 minutes. You have, I think there's 6 problems there, are there not? Right? There are 6 problems there. The first 3 I gave you a hint. The last 3 I did not. Show the formula, show the variable, show the formula, show me your solution. I'm going to come around and help. I need at least the first 3 done before you leave.